Alright, welcome back everybody. In this video we're going to look at example 3 from the Implicit Differentiation 2 lesson. So we want to find points on the curve 2x squared plus xy plus y squared equals 14. First, where the tangents to the curve are parallel to the x-axis, and second, where the tangents to the curve are parallel to the y-axis. So let's think about what that means. First of all, for part A, in order for the tangents to be parallel to the x-axis, we need the slope of the tangent line to be 0, which means we're looking for points where the derivative is 0. Okay? And in part B, we're looking for a slope that is undefined. So we're looking for points where the derivative is undefined. Okay, so no matter what, a good first step in our solution of this problem is going to be to find dy dx. So I'm going to go ahead and take the derivative of this using implicit differentiation. The derivative of 2x squared is 4x. Derivative of xy, I use the product rule, x times the derivative of y, plus y times the derivative of x. And then the derivative of y squared is 2y dy dx. And the derivative of 14 is 0. Okay, now solving this for dy dx, we've got x dy dx plus 2y dy dx is equal to negative 4x minus y. And so dy dx is equal to negative 4x minus y over x plus 2y. And now that we have the derivative, we're ready to start part A. We're looking for where the derivative is equal to 0. Now, in order for the derivative to be equal to 0, we need the numerator of the derivative to be equal to 0. So we're looking for points that are solutions to this equation. And gives us y equals negative 4x as a relationship that exists. For any points that are on this curve where the derivative is going to be 0, it has to be true that y has to be equal to negative 4x. Now, I'm still not quite where I need to be for this part because I'm looking for points. And the points are going to be points that satisfy this condition that are on the initial curve. And so what I really have here is I have a system of equations that I need to solve in order to find these points. And so, since I know that y is equal to negative 4x, I'm just going to take this equation and everywhere where there is a y, I'm going to substitute in a negative 4x. That gives me 2x squared plus x times negative 4x plus the quantity negative 4x quantity squared is equal to 14. Now I want to solve this equation for x. Got 2x squared minus 4x squared plus 16x squared equals 14. Summing all those up, I get 14x squared equals 14. So x squared equals 1, which means that x is equal to plus or minus 1. And so my points for this portion are going to have x coordinates of positive 1 and negative 1. Now I need y coordinates, and I can choose to substitute negative 1 and 1 back into either of the two equations in my system. Pick this one. It's much more complicated to substitute them back into the original. And there we go. There are our points where the tangent line to the curve is parallel to the x-axis. Now I need to handle part B. And in part B, we want the derivative to be undefined. In order for the derivative to be undefined, the denominator of the derivative has to be equal to 0. So we've got that same scenario. I'm going to solve this for x. I could solve it for y, but I'd rather work with whole numbers than work with fractions. And now we're in a scenario again where we want to take this equation and the original and solve that system. So we're going to substitute negative 2y into this function, into the original function, everywhere where there is an x. And now we're going to solve this for y. We've got 2 times 4y squared, that's 8y squared, minus 2y squared plus y squared equals 14. Combining, we end up with 7y squared equals 14. So y squared equals 2. And so y is equal to plus or minus square root of 2. So those are the y coordinates of our points. And now all we need is the x coordinates. We can substitute into either of the 2 original equations from our system. Use this one because it's a lot simpler. We end up with negative 2 root 2 and positive 2 root 2 as our x coordinates. And there are points that are on the curve where the tangent line is parallel to the y-axis. Alright, that's a nifty problem. A lot of application for us there. I typically find that people, when they try and solve this problem, they tend to stop at these relationships right here because they don't stop and think, hey, I want points. My answers need to look like points. So I go through the rest of that process to solve the system and find the points. Alright, that's the end of this video and the end of the lesson on implicit differentiation, second derivative, and applications. I hope you guys enjoyed it. See you next time and have a great rest of your day.